Hello everyone, I'm Dr. Sandeep Paul Chaudhary, and this course will deal with the physics syllabus of class 11 12 for the CBSE one. Today we're going to discuss about the syllabus of class 11 and the part 1 of that book. You basically have two books in class 11, and if you look into the syllabus, you'll get a basic understanding that things that you're going to learn, you already have some kind of exposure to those kind of topics. So the very first chapter, it starts with the physical world. A point to note here is that the first chapter that we are basically talking about is not very important, because we usually don't have any kind of questions which will be coming up. But in order to generate some kind of interest in the subject of physics, the first chapter has been put in, and there also you come to know across some of the uh, beauties of physics, like let's say the fundamental forces in nature that is present and that is also discussed in this particular chapter. The very first chapter from the which the questions are probable is units and measurements, and we have a system of units here which we call basically the SI system, and we have an understanding of the SI system of units. Apart from that, we also talk about some of the instruments, for example screw gauge and vernier caliper. We also see that there are some errors in measurement whenever you are doing any kind of calculation. So those kind of errors we basically try to understand. So this particular topic is not too long, but it's important for doing calculations the correct way. Connected with that, we have something which is called significant figures. That's there, and then after that, something which is more important for scoring marks in your exam is the dimensional analysis. Now here we basically talk about the physical quantities and what are their dimensions. For example, let's say length is basically represented within by L within boxes, and that represents our dimension. So any kind of physical quantity, let's say force and all, everything can be represented in terms of dimension. Then we discuss some dimensional formula and dimensional equations, and also some dimensional analysis and its application. The dimensional applications are not very vast, but there are some applications which we must know, three broadly speaking. Okay, so the next topic is motion in a straight line, that comprises the third chapter of your syllabus. And here we are talking about motion in one dimension. That means, let's say for example, a car is moving in a highway in a straight line, and what kind of motion and its analysis, those are the parts that we'll be studying in this chapter. So we have some concepts of scalars and vectors here, although not in very detail. We have average velocity and average speed, which you must have already read in your lower classes. Also talking about instantaneous velocity and speed, that means the velocity and speed at any instant of time. Apart from that, we have definitely acceleration. Velocity and acceleration are closely related, as you already know. And the kinematics equation. The kinematics equation you must have already studied. S is equal to ut plus half at square, v square is equal to u square plus 2as, and v is equal to u plus at. Those equations are derived here graphically, and as well as using some calculus method. Apart from that, we have relative velocity as the final topic of this chapter. The next chapter is motion in a plane, and that's chapter 4. And here we talk more about scalars and vectors. So by plane, I mean we are talking about a two-dimensional system. That means we have a x-axis and a y-axis. We'll discuss more about vectors. How does it behave when we're basically multiplying it with real numbers? Also addition and subtraction of vectors. So this particular chapter deals more with vectors. Finally, after an understanding of vectors, the motion in a plane is discussed, and then what happens to the motion when there is a constant acceleration in place. We also talk about relative velocity in two dimensions. By the term relative, we mean that if we're considering two different bodies moving at the same speed or this different speed, or same velocity or different velocity, what will be the relative velocity between them. So that's an important part. From examination point of view, for descriptive questions, projectile motion is a very important topic, and it's also important for your entrance exams. Projectile motion, in simple words, we can say whenever we are throwing something, let's say for example we are throwing a cricket ball, it basically will follow a parabolic path, and the analysis of that path is something which is dealt with in this particular topic. So it basically follows a parabolic path, and that's the motion that it follows, and it's a projectile body, and we are going to analyze the different aspects of that motion. And we also talk about uniform circular motion, and here we also talk about something, a body which is moving in circular motion, and what's its centripetal and centrifugal force, and those kind of topics. The next chapter will deal with laws of motion, and that's the fifth chapter. The first topic, Aristotle's fallacy and the law of inertia, is basically leads to the Newton's laws of motion. And you very well know that there are three laws of motion, and we will have an elaborate discussion on these three, apart from some numerical problems. These laws also deals with the conservation of momentum. So momentum is also a very important part, because the second law says more about momentum, because it says that the rate of change of momentum is directly proportional to the impressed force. And so this is important, so it's an extension of the second law. We're also talking about equilibrium of particles. It's a simple concept. And then common forces in mechanics, we discuss more of circular motion here, and we talk about problems like bending of a cycle or skidding of a car, and so on. And then we have some problems which will basically solve in mechanics, which is actually very important to understand. The next chapter is work, energy, and power, and all three of them are actually interconnected. And we also have something which is called the work energy theorem. We have work, and we know the unit of work is joule, but the unit of kinetic energy or any kind of energy, we're talking, let's say, potential energy, is also joule. So obviously work and kinetic energy are interrelated. So that discussion we are going to do in this particular chapter. We are going to extend our idea on work energy theorem for a variable force, and then we are going to discuss the concept of potential energy. When we're talking about mechanical energy, it has both kinetic and potential energy involved in it, and how it is basically conserved in a system. So speaking more of potential energy, we talk about a spring. Now when we talk about a spring, and suppose we're pulling the spring and holding it in a particular position, it has more potential energy stored. So those kind of concepts we are going to discuss here. We're also going to talk about Hooke's law in this particular concept. Then we can talk about the various forms of energy and how it is related to the laws of conservation of energy. Finally, we'll come to power. Now power is important because power is also related with work, because power is equal to work done per unit time, so that's again important. Apart from that, we are also going to talk about collisions, about elastic collision, inelastic collision. In simple words, when two body collides with each other, what is the equation that is formed, and what are the studies that we can perform from there. The next and the final, the second, penultimate chapter of this book one is system of particles and rotational motion. I'd like to bring to your notice that this particular chapter is kind of complicated, and if you understand it, it's easy, but if you are superficially trying to understand this chapter becomes kind of difficult. But it's at the same time important from your examination point of view, because here we are going to learn the concepts which probably you have not learned that much in your lower classes, or you might have only heard about it. So we're talking about center of mass, and and we're talking about linear momentum of simpler system of particles. We continue with some more concepts of vector, and we talk about two vector product, which you will also learn in your maths class. You are going to talk about angular velocity and its relation with linear velocity. So when we're talking about something like rotational motion, angular velocity comes into the picture, because when a body is rotating, the velocity, which is linear velocity in a one-dimensional motion, might not be behaving same with respect to angular velocity. So we need to understand that. Similarly, we have got torque, which is nothing but the rotational analog of force, and so on. And we have angular momentum, and then we also have something which is called the moment of inertia. The moment of inertia is something which is equivalent to mass, because when the body is rotating, the mass kinds of behaves in a different way, and we basically term it, not exactly term it, but we have the concept of moment of inertia, which deals with the mass in rotational motion. Related to that, we have got two theorems, which is the theorem of perpendicular and parallel axis. The statements are more important than the proof for these two, because you are going to also solve some numerical problems of this. So we are going to talk about the kinematics and dynamics of the rotational motion about a fixed axis. By fixed axis, I mean, let's say you are talking about the opening and closing of a door. The door is fixed at the hinge, so that will be the axis about which the door rotates. So we're going to talk about something of those kind of problems, and then finally we're going to talk about angular momentum in case of rotation and rolling motion. So suppose you are rolling a body on an inclined plane, what kind of motion does it follow, what are the equations connected with that? We're going to study that. In the final chapter of the part 1 of your class 11 book, we have gravitation, and that this chapter should cover the half of the syllabus of your class 11 physics knowledge. And then we have in gravitation we have something which we call as the Kepler's law, but this time you're not only going to understand Kepler's law, you're also going to prove Kepler's law. Similarly, we have got universal law of gravitation, which you already might have learned from your lower classes. Then we have got the gravitational constant, which is capital G, if you remember. And also you have studied about acceleration due to gravity in your lower classes, which is nothing but small g, denoted by small g. Value becomes 9.8 meter per second square. So acceleration due to gravity below and above the surface of the earth is definitely different, and we will study that. We also talk about gravitational potential energy, and we talk about the escape speed. Now you must have heard about satellites which has been launched into the orbits, or the spaceships which actually goes into space, with what velocity they should be launched, and that kind of concept is discussed in escape speed. And we also talk about Earth satellite. Now you know the artificial satellite and a natural satellite. Earth has got something which is the natural satellite, the moon. We're going to discuss on those kind of topics. And then we're also going to talk about the energy of these orbiting satellites. We're going to talk about geostationary and polar satellite. This is just a discussion, and it's not very complicated. It's not even vast. It's a simple topic. And then finally we have got something which we call as weightlessness. Now when you get into the lift and the lift is moving up, you kind of feel weightlessness. So that kind of phenomenon we are going to study in this particular chapter. So that's all for part 1 of this syllabus, and I hope that the with the lectures that we're going to do in future, you're going to understand the subject in a better way, because I'm also going to present some more innovative techniques by showing you some videos to the relevant topics. Thank you. Bye for now.